The first step in running the AstroImageProcessor program is to download it from the internet. The program can be downloaded from a Google Code repository shown with this address in this address bar here. We'll need two jar files, one the launcher.jar and the AstroImageProcessor.jar. We'll take the launcher first, save link as, go to the desktop folder, save that. It's been downloaded. Next thing we'll do is save link as, save. Now I've downloaded those two programs, and both programs, it's important that both programs sit in the same folder. If they're in separate folders, they won't work. The program that you always want to use is the launcher. The launcher sets the memory up for the processor jar. So you never launch the processor jar by itself, you always use the launcher. You double click on the launcher, the program is opened, the memory is declared, and the next step is to start processing images. Opening the file. To open a file, click under the File menu, Open, navigate to where the file is, and you can see that the program only takes FITS images and will only look for files of these extensions. The image is opened. Here's the main panel where the image is displayed. Here is a display panel which changes the transfer function, also how the image is displayed as well. This will show how the minimum and maximum pixels that are on the display, and the zoom panel. Once the image is displayed, it might be not exactly how you would like to be able to see it. It might be too dim to see it. You can enhance the display but not change the data by changing the scale. So we can bring down the maximum value of the pixels and brighten up the scale. And then we have a lot of sky background, so we can bring up the minimum value. And now the image is displayed much more easier for us to see, and then you can, but that does not change the data. The transfer function panel. The transfer function panel controls how the image is displayed as far as how is dark and how the lights are light. So the linear transfer function is how the camera actually takes the image, and it's very hard for our eyes to pick it out. Our eyes are more sensitive to dark than they are to light, and that's mimicked by the square root transfer function. For a little bit more contrast, you can use the log transfer function, and for even more contrast, you can use the sine function. The default, and my favorite, is the square root transfer function. There are other options for displaying the image that does not change the data that might make the image easier to see. One can invert the image, which changes the black for the white. A color spectrogram could be made in which red indicates intense pixels, purple indicates dark pixels, and you can also invert the color spectrogram, and so that you can now make out other objects that might be more difficult to see otherwise. Note that this doesn't change the data, just how it's displayed. The zoom panel. With the zoom panel, we can look at details in the main panel. So clicking anywhere on the main panel, over here for example, will change the zoomed in image, which is 1/9 the size of the main image, so that one can see more details. So you can click anywhere you would like in the image, and you can highlight that image that could be used later on for alignment. Removing hotspots. On the image, there are some pixels that are much higher than they should be, or much brighter than they should be. So for example, you can see that this pixel here looks like what we would call a hotspot. This can be removed under the Clean menu, which will go Clean, Remove Hotspots, and now you can see that that hotspot has been removed from the image. Now, it hasn't just done in the zoom panel, it's gone through the entire image and removed all the hotspots, not just what's in the zoom panel, but everywhere the hotspots are removed once you clean the image. Saving the image. Once I've done something to the image, I would like to save it. I don't want to save it on top of the original image. I'd like to keep the original image in case I'd like to go backwards. What the program does is it suggests a file name, and the suggestion of the file name is down here, where it took the original file name and it put the operation where we had previously removed the hotspot and added it to the file name. Now that's what it thinks the file name is. So when I go to File, Save as Fits, which means it will save as a fits image, it adds that additional operation to put in there, and now I can save that. And now I've saved this file instead of rewriting on top of the original data. Once the hotspot has been removed from one image, it has to be removed from all the images that will be used to produce the final color image. So we'll do that for every image. We have to do it for the dark image. Remove the hotspot. And now you can see in a unique feature of the program that it always auto-scales the image. So now that one hotspot has been removed, the screen has been auto-scaled to show that. Now we can save that image with the right underscore, save. And now we go through doing that with all the images. Once all the hotspots have been removed from the images, the next is to subtract the dark images. But before I do that, I want to reorganize my folders so as not to get too confused. So what I've done here is I've made an image folder in which I have my raw images here. And now I've made a hotspot remove folder. And you can see this is where I've removed all the hotspot files are placed here. And now I can operate easily in this folder here without having to be confused by the raw images. Now we're ready to start subtracting the dark image from the other images. The dark images was taken with the shutter closed and has a and it was used to remove the pedestal from the other images. So let's open up an image. I'll open this one here. I'll probably change the scale a little bit so I can see what's going on. Bring down the minimum. And then I'll go to Action, Subtract. I'll pick the dark file, and now it subtracts that file from that. Now I've removed the pedestal. I want to save that. And you can see I put the underscore, the program automatically puts the underscore sub to let you know that you've removed the hotspots and now you've subtracted a dark image from that. Once the dark image has been subtracted from all the other images and I've saved the files, I want to do the same trick again by rearranging my folders. So if I go over to my images, you can see I had put all the hotspot removed images here. Here's my raw data. And then I made another folder called Dark Subtracted, in which all the subtracted images have been put here. And now I can operate on those easily without, again, getting confused. The next step is to align all the images together. To do that, I open the image I want to align. I say Action, Align. It asks for a reference image to align to. I'll just pick this image here. You'll notice a couple things that have happened. There have been two image places on top of each other. The blue image is the reference image. The red image is the original image that you want to get aligned to. Another thing is that an align panel has popped up in here, and that's what we'll use to align it. The first thing we'll do is we'll pick a target to take a look at for the alignment. We can see the red and the blue are not aligned. We'll use the buttons here to move the red image on top of the blue image. When we're satisfied with the alignment, we then want to save it. We don't use this save button anymore. We have to use this save button here to close the alignment panel. It puts the align underscore there. We save it. And now the image has been aligned to the reference image. I need to align all the images from an observing session together, just not one. So I'll go through and open up another file, Open, and I'll pick this image here. And then I'll want to align it, Action, Align. And it remembers the same reference image. I'll just say Open, and you can see now it's not quite aligned. Move the red guy over, down a little bit. That looks a little bit good. Again, save to close the panel. The name that's given, save. And I'll go through and I'll do that for all the images. After all the images have been aligned to each other, the next thing I want to do is put those aligned images into the same folder. So I'm going to do the same trick I did before, in which I had my hotspots removed, put them all in a folder, dark subtract, put them in a folder, and I put all my aligned images into the same folder. You can see I've done the hotspot remove, subtracted, aligned. The next thing you'll see is that I have multiple images with the same filter, 2 R's, 2 I's, 2 G's. I did this because I did not want to track for a long time while taking data with the telescope, and I wanted then to be able to get good signal to noise. I'm going to add 2 images together to make them even a brighter exposure. So I can do that by adding images together. I use the program by first opening an image I want to add. I'll navigate to that. I'll pick a G-band, and then next thing I'll do is add an image to it, which I'll pick the second G-band. Now the 2 images have been added together, and now I'll save that image and see the add on it, and I've saved. So now these 2 images have been added together. I'll continue adding the next filter. Open that file, the next filter file, which will be the I-band. I'll add the other I-band to it, which is this file here. Now the 2 files have been added together. I'll then save file, save as fits. You said I've added the 2 I-bands together, save, and I'll continue this process on the R-band as finally. Once the images have been all added together, the next step is to normalize the images so each image has the same strength. Again, I do the same trick of putting all my added images in a separate folder. You can now see I have 3 images in which the following operations have been done on them. Hotspot removed, subtracted, align, and then added it. So let's start normalizing. First thing we'll do is we open an image. I'll pick this first added image right here. And the next thing I'm going to do is I'm going to want to normalize that. So I have to pick a reference, put the normalize function. And it's going to want to say, which image do you want to normalize to? I usually pick the R band because it's the brightest. It's been normalized. I now save. It puts the normalization tag on, and I've saved that. Now I have to normalize all the images together. So again, I'll open the next image, which will be the I band. I'll action, I'll normalize it. Remembered the reference image to normalize it. It's been normalized, and I'll save that. And then I'm going to normalize the third image. File, open. I really don't have to do this, but for consistency, I'll normalize it to itself. Action, normalize, open. And now all 3 images have been normalized together. And I'll save that. The final step is to make an RGB plot from the normalized images. Again, I've gone over to my images, and I've put all my normalized images in their own folder. So you can see the 3 normalized images: hotspot removed, subtracted, align, added, normalized. So now I'll make an RGB plot out of those 3 images. We'll go to RGB plot, say create RGB plot, and we'll pick the folder, which is normalized. The first thing it will ask is for the red file. That's the I band. The next thing it'll want the green file. That's the R band. Finally, it was on the blue file. That's the G band. So now we have the 3 images. And now there's a new panel that shows up, which is called the RGB panel. And what I can do is this sliders here give the gain of the panel. Okay. And then I can also change the maximum intensity as well. I can change the minimum intensity, probably not that much. And by playing around with the different colors, I can change the color of the image. I can change what shows up. I can change the transfer function. I can change the transfer function until I find how I like the image to look the best. This looks somewhat nice, maybe a log. Okay, maybe boost this up just a bit. No, not that much. Okay, so there's the image that I've added together. And when I like that, maybe I can take this down a little bit in gain. Okay, I like what I see. I save it. And now I can save it as a PNG file. And now the image has been saved as a PNG file. I saved the image as a PNG file, which can be used by any graphics program to take a look at that. So we'll go ahead and take a look at that. I'll file the images. Here's the PNG file, and my Windows system knows how to open up. And now this is a program. This is a file that I can put on any web page or send to anybody else. It's not a FITS file. It's a PNG file with different colored images. So those are the steps in producing a color image using the AstroImageProcessor program.